Okay, I want to work a problem for you that involves rationalizing the denominator where the denominator has a cube root in it. So I'm going to do this problem a couple of different ways. The first way I'm going to do it is a little bit different than what's in the book. And then I'm going to go ahead and do it a second time, doing it the way that they do in the book. So look, if you have a little trouble with these things, it's not a big deal. It takes a while to get used to these cube roots and what you're trying to do, because you have to pick the thing that you're going to use to rationalize the denominator. You can't just look at what the denominator is and multiply by that thing itself. You have to think about it a little bit more. So it's a little bit more complicated than doing square roots, but I think you're going to like it. Okay, I want to simplify this expression, which means I want to rationalize the denominator. I'm going to do it a little bit differently than they do in the book, and you can see what you think. So I'm going to start by multiplying by 1 in the form of cube root 4 over cube root 4. And I see when I multiply in the denominator there, I'll have the cube root of 4 squared. Well, what I need is the cube root of 4 cubed, so I'm going to just do this again. Cube root of 4 over cube root of 4. Now when I multiply in the numerator, I'm going to get 7 cube root of 4 times 4, which is 16, all divided by the cube root of 4 times 4 times 4, which is the cube root of 4 cubed, which will just be 4. I'm almost there. I need to just simplify a little bit more because I see that 16 is 8 times 2, and 8 is a perfect cube. So I'm going to write this now as 7 times the cube root of 8 times 2. That's all divided by 4. I'll continue to simplify 7 times 2 times cube root 2, because that cube root of 8 comes out from under the cube root symbol as just 2. That's all divided by 4. And now I see I have a 2 common to the numerator and denominator. I divide that out, and I have my answer 7 cube root 2, all divided by 2. Okay, I want to do this problem a second time, and so here's what we did the first time. We looked at this denominator, cube root 4, and we multiplied by it twice here because we knew that would give us cube root of 4 cubed, and that just ends up 4. But we can save ourselves a little time sometimes if we notice that this is 7 over the cube root of 2 squared. So I've got 2 squared in the denominator. If I multiply again by 2, or cube root of 2, I'll end up with 2 cubed under that radical. So now this time, when I multiply, I don't multiply by cube root 4 over cube root 4. I multiply by cube root 2 over cube root 2. Now, if you see that, and it takes a little bit, it takes a little practice with this to be able to see that, but once you do, look at the numerator, 7 cube root 2, and the denominator is cube root of 2 squared times 2. Well, when I add exponents, I get 2 to the third. Okay, I have the cube root of 2 to the third. Numerator stays the same, and in the denominator, just 2. So it's a little quicker this way, but you have to understand that this is a 2 squared. You have to see that first to know to multiply by this. This always works, regardless of what's in the denominator. If that's a cube root, and you just multiply by it 2 more times, you're going to have the cube root of whatever's underneath that radical to the third power. So that always works, but this works a little quicker and a little more efficiently, and involves a little bit more sort of quantitative reasoning, where you're sort of noticing already that you have 2 squared here, so when you multiply this by this, you end up with cube root of 2 cubed, which is just 2. But either way works. Both of them work just fine.